Hi everyone, welcome. Thanks for coming. There's like three more chairs here if you guys want to sit. 1, 2, 3, I think.
I guess I'm blind.
All right, there's 2 more. Second row. All right, let's get started. Welcome, Web Performance in the age of H2. So, my name is Holger, and basically, bottom line is today we're going to talk about how to get from Turtle to Rocket. As with everything I say today, is like a lot of times your mileage may vary. I came a lot of like different cases where like things suddenly didn't make sense, even though officially they should make sense. Also, it very much depends on like the project you're working on, because like every project has like different requirements, and sometimes some things that might work for you doesn't work for you. So. This all started 2013. I went to Smashing Conf in Freiburg, and my friend Brad was speaking there, and he was speaking about how performance is invisible. And this kind of like struck with me, and I started to think about it. And then there was another thing he said where it was performance is design, where he talked about like how performance need to be incorporated or like thought about like very early on in the design process. And this really like kind of like started my thinking, and since then I've been digging deeper into web performance and how we can actually contribute in like making the web a little faster. So that was like 2013. That was like pretty much like the first time I think people started, or like about that time where they started to speak about like how performance is very important and we should really care about that and we should do something about that. So that's like almost 3.5 years or so, and since then we've come a very, very long way, but still, I think we still need to work harder on like actually implementing better techniques and like spreading the word and getting people to understand how this is like an important thing to consider, and like actually, as I mentioned before, like consider it early on in the design process, because you can't just like kind of finish your project and then like pluck it on. It's kind of doesn't really work. Still, somehow, we still live in a world of bloat, and there's like things where like I'm sure every one of you comes across every single day, and I do too, which a couple of weeks ago, I came across this one after the iPhone was released, 13 megabyte, the site clocks in, and I was like, whoa, this is like actually really too much. Not an uncommon thing to see. So, fortunately, there's like been a lot of research, and this is a great site where all those like research is like collected, where like it actually has like proof on like how it makes a difference and like how it actually affects your return on investment or like sign-ups and so on. So this is like a really good resource, and it kind of helps like to back up the theory of like how performance is important. Then Facebook came along with like their instant articles. I'm sure some of you might have seen that, and it is really that fast. It's just like boom, right there. So they kind of upped the benchmark again, and like we're kind of like trying to achieve that as well, because like this is not the final solution, but still like a big step forward. And what Facebook did, basically, they started to implement that because they wanted to like make the web or their stuff faster for like emerging markets, because not everybody lives in the luxury that we do. I mean, I went to Vero Mall, got a SIM card, 4G, 4 gigabyte, €4, and I was like, wow, this is awesome. This is not a normal case. Like this varies, and especially like I'm from Asia, or like I live in Asia. I'm not from there, but basically, if you go to the Philippines or Indonesia, suddenly like reality kicks in, because like I've been at a conference in Manila 3 weeks ago, and basically, if you have reception, that's already quite good, because sometimes you're in car and traffic is manic, so you're 2 hours in a car, and out of those 2 hours, maybe an hour or so, you don't even have reception, no data, nothing. So we live in the luxury world, and if we talk about slow, we actually have like kind of like first world problems. But anyways, this is like why we need to actually work on that much, much more and much harder. Then Google came along and they said like, okay, hey, we're using site speed to actually add that to our ranking factors. So suddenly when Google speaks up, everybody goes like, oh my God, I have to do something about it because Google just said that. Same with like mobile friendliness and so on and so on. Then they started with AMP, Accelerated Mobile Pages. So this is like fairly new, kind of like I don't know which side I'm on. I'm not a biggest fan. The idea is great, but I don't know. Anyways, this is like also like a big move towards that direction of like getting things faster. And as we all know, people don't like slow, and 50% of people say, okay, I don't like pages, and I just leave them when they take longer than 4 seconds to load. This value varies a bit, because like some people say like 3 seconds, 4 seconds, 10 seconds, whatever. I think 4 seconds is actually a fairly normal measure, and a lot of sites still take 4 seconds. But we get the idea. We need to be faster than what we actually are right now. So this is a nice table and like a nice overview, like what happens in terms of like user perception with like different times. So like 100 milliseconds, and that's like kind of Facebook's instant articles, I suppose. It's like super fast, and that's instant. Once you reach like 10 seconds, forget about it, you're gone. So logical conclusion, faster is better, and this is like why we're all here today, and want to actually work on getting that thing faster. All right. So then there's like perception of time. And we all know like once we're not busy and we're not entertained, we could get bored very quickly, and it happens all the time that you kind of like have to either wait for something or you just hang out, and it's kind of like nothing happens, time moves very, very slowly. There's like tons of these examples, and one of my absolute hate moments is when I hit this, because why would anyone actually do that? So nobody likes to wait, and if we're looking at the definition of waiting, we actually quickly see it says like the action of staying where one is or delaying action until a particular time or event. So what sticks out is delaying action. Nobody likes to delay action. Why would I want to do that again, you know? So then there's like perception and how your brain actually works, and how your perception actually makes you feel that certain way. So it's a fact that like fast websites create happier users, and unhappy users just get done less stuff done, or even what we said before, they're just going to leave your site and go somewhere else. So there's also lots of research. This is all from like a UK study, where it says like, okay, many people, they're basically unhappy, they feel inconvenienced, they don't like when stuff is slow. This is particularly interesting because it actually says like people perceive stuff to be slower than it actually is, and that's like 15%. That's like a substantial amount of time. And one that actually really sticks out is this one. After like people had the experience and they recalled that, they say, remember it like 35% slower. And this is like massive. I mean, 35% is a substantial amount, and even though it hasn't been so bad, people think, oh wow, this was really bad. So we spend a lot of time waiting, and apparently that's about like 9 minutes per day just waiting on wait, you know? I was thinking about that. So I've been doing this for like about 19 years now, and just remembering like 56K modem times, and like reloading and reloading. I don't know, I probably do that like, I don't know how many times in my life I've done that. It must add up to massive amounts of time. So anyways, this research has been like happening for a very, very long time, and these numbers are like always constant, and technology changes, but like those facts from research and those numbers, they just never change. It's like a constant thing that's always there. So there's not much we can do about it. And as I said, like the memory processing. So there's like 3 types of memory processing, and that's like sensory, short-term, and working memory. And the sensory memory is like the one that is in charge of like visual, audio, and touch. And of course, we want to focus on the visual, but that's like the very, very short-term stuff, where like happens in milliseconds. And that like then passes information on to short-term memory, which is kind of like, right now, in our case, not that important. So sensory memory is, for example, in charge of like, I'm sure everybody has been on a beach and you've seen those like fire jugglers, or like even like sometimes photos where people like write stuff with their cigarettes. So once you want to see that like continuous circle of like the fire swing, it's like 100 milliseconds for one turn. And this is like where that magic number 100 milliseconds comes from. So we want to try to like do things like really, really fast, and at least like the perception, even for animation and all that, is kind of like falls into line with that. Another thing that like goes hand in hand with that is flow. And this is like even a bit more important, because flow is something that has been established over many, many, many hundreds, thousands, millions of years. If you do things, you do them in like a constant flow. You never like kind of pretend like you're a robot, like you're moving like this. You just don't do it. It's like whenever you're cooking in the kitchen and you just stir your stuff, and then you walk over to your cutting board and you get your veggies and put them in the pot. It's all like a constant movement. It's like never like a robotic action. And once you break that flow, this is like where problems occur and where it starts to feel very, very unnatural. So again, we want to try to keep that flow going and not break it, so people feel like more comfortable doing things. So faster pages definitely like correlate with increased user engagement. And the interesting thing is, like, if that is not the case, and if people feel like it's bad, it not only makes them feel like, oh, things are slow, it even has like a bad perception on brand, and even goes down to content, design, navigation. So basically, you could say, slow site, people think your brand sucks. It's maybe a bit extreme and a bit blunt, but that's the basic idea behind that. So, as we said, we function the best if things just like keep going fast, and if like we can respond, or like stuff responds to our actions like quickly. Slower stuff might work, and we do that every day, because as I said, there's like many pages that are really slow, and we adapt to it, but it's never perfect. It never feels right. So, and again, like perception, this is an interesting story, because I went to France 2 months ago or so, and of course, Bordeaux, you drink a lot of wine, so I came across this app, which basically lets you analyze a wine label, and then like gives you information on like, okay, what wine is that? It has ratings. You get like a price, which kind of is sometimes really frustrating. But it was interesting. Then I was back in Hong Kong, and I went to like one of those outlying islands, and usually Hong Kong internet connection super fast. You go to those islands, and it's not as fast anymore. So maybe you get like 2 Mbit. Down, up, not even up, but it can be very slow. So I tried that app, and I was like, okay, scanning a wine and see what happened. It was really interesting. So it goes uploading, analyzing, and usually then it would give you the result, and it just kept going. And I was like, whoa, hang in there, cool, okay, yeah. And then it started to become funny. All right, not bad. Almost there. And this was what I really liked. Because this is like respecting users' time, where people go like, you know what, okay, it's taking forever now. Forget about it, we take care of it, and we'll send you a push notification once we're done. Do something else. And I was like, wow, this is really cool. Because I did think, okay, this is like really slow. I mean, it's not their fault, obviously, because I know it's the network, but for normal users, it might be, okay, this is just a crap app. But in the end, it was like, I was kind of delighted. I felt like, wow, this was fun. And I got there, and suddenly I was like, okay, this is really respecting me. And as I just said, like, I will always come back to this app because it's great. And I was like, okay, I'll forgive you that slowness, because that was just so entertaining. So this is like how you can switch around that perception of something is slow. Whereas like if I just get a spinner, I go like, okay, thanks, I'm out of here. Oops, skip that one. So even though I said like perception can change things, sometimes you have like those hard numbers that you can measure and analyze and all that, but the hard numbers might be great, but it can still feel too slow, or like kind of not right. So don't get tricked by those hard numbers. And sometimes things just can like, your perception can be very different from like what the real numbers say. So it's always a matter of like, you get the numbers, but you still have to find ways where you go like, okay, this kind of feels better. All right, so a bit more to the technical part. I'm sure everybody is like kind of somewhat familiar with like basic performance optimization and stuff, but I'm just gonna run through a few things here. But first of all, you wanna plan and create a strategy on like, what do you wanna do? How do you wanna optimize for performance? So in general, one thing that's really important to remember, this is like all the process. It's like not a one-off. It's like a continuous thing. You have to implement optimization, then you test it, you validate it with users, and then you go over and over and over. And then you might think, okay, what are we analyzing? What are we actually optimizing? What are we working on? So it's quite interesting because you can do so many things. But if you look at this, basically, most of the stuff happens in the front end. You can do server, you can do network optimization, but your actual gains are in front end. So that's about like 75%, and I would recommend start there and then take care of the server, because this is like the lion's share of like the optimization part. So what's the best strategy? There's probably many answers to that as well. I found a really good quote by Chris Coyer, which basically reads, step 1 is like you have to care about performance optimization. Step 2 is like you start to make things better. And the third step, you stick on it and you keep on continuing doing what you do, which basically kind of correlates with what I said earlier, that you have to like kind of follow that continuous process. There's like not a one-off where you go like, okay, done, I'm good. You can do that, but obviously there's always much more to do. So 2 days ago I was going over my talk and I was like kind of revising some of the slides, and I thought like, okay, hey, this is like actually TFDI, which I was like, oh well, this is kind of cool. I'm gonna use that. So TFDI stands for test, find, decide, and identify. And first you want to test your performance. Then you want to find your bottlenecks, and you probably like might find many of that. And then the important part is like pick the ones that you think are important for your project. As I said earlier, this may vary for many different people, projects, and also you want to pick the ones that like maybe you find useful, you think that makes most sense, and so on. And then you identify the low-hanging fruit, because this is like where you put in very little effort and you actually have a lot of gain. Whereas like later we will see you put in a lot of effort and you get out this much. So it can be very time consuming to chase after milliseconds in the end. But if you follow that and then you rinse and repeat and you just keep on doing that and keep on doing that, then you will see that you actually will find less bottlenecks and less and less. And I mean, you can go on doing that forever, but I think the first couple rounds you do that, you have a lot of gain with like very little effort. So we all know waterfall charts, so this is like an important one where that I work with every day, and probably you guys do too. We find that in Webpage Test and Chrome DevTools, and two of the important things we also need to realize is like DOM content loaded and document load. So these blue and red line, I'm sure everybody has seen those before. These are like two important markers. And what we're also going after will be like first paint, which is basically the time you see something on screen, which most of the time very much correlates with like the blue line. It's very close most of the time. Another cool tool that I use a lot is like the throttle in Chrome DevTools. So you can like simulate whatever, hanging out in Manila if you want to, so you can try that. It's a very frustrating experience at times, but you actually get a good sense for like how other people might feel. And it's really interesting if you try to try that on a few sites, you start to understand what like pain some users are going through. And as I said, we live in luxury land, but try this and it will open your eyes. So Webpage Test, I just mentioned, also a good tool to analyze your stuff. And there's like one thing in there that is really helpful, which is like the film strip. So this gives you basically a breakdown in frames, and you can specify what time intervals, and you can actually exactly see what happens when the page gets rendered and which elements, and like also helps you identify those bottlenecks where you see like, okay, there is like definitely a problem. Because if you see like 5 of those frames white, you definitely have a problem, because that means like 5 seconds or so, like nothing. You can export as a film strip, and this is actually from Manila, so this is like one of the news sites. So you see, 3 seconds, and then it starts slowly rendering. Painful experience. Load at, I don't know, 12 seconds or so? 13, so that's quite slow. Another important thing that we will need to know is speed index. Speed index is basically like a number that describes the performance from like a user's point of view, and it indicates the, how much of the page in your viewport, or the visual viewport, which means like everything above the fold, will be displayed. So it will give you a curve in the end, and everything above the curve, the more space or the more area you have above the curve, which we'll see in a second, means like that is the time, the longer or the more the user sees like a blank screen, which is something we really, really want to avoid. Otherwise, we can go back to that first slide, put a spinner, and just go home. So to give you an example, speed index, so on the left you see the time, on the right you see the percentage of visual completion of that visible viewport, everything above the fold, and that's important because the speed index will change from mobile or a desktop because it's like different sizes, obviously. So in this case, you have like 500 milliseconds, like 30% of the page is, or the visual is rendered, and then at 1200 milliseconds it's 100. And if you put that in a graph, it looks something like this. And what I said before, that area above the graph, that's like how long or like how much the user will see that white space. So you want to try to get that area as small as possible. Here's another example, which is a little bit better. So we see, okay, hey, at 200 milliseconds, we're almost like 20% there. So that's actually quite all right. It's fiction. I made that up, but it's doable. And then it goes all the way down, 1200, you have fully rendered, and that graph looks like something like this. So you see that white area above the graph is like much, much smaller, which means like you get stuff on the screen much faster. Another helpful tool is Google PageSpeed Insights. There is another one which like sits on top of it, which looks a bit nicer now, also Google. You can throw in your URL, and then it gives you like pretty much a nice rundown of like whatever mobile friendliness, performance on mobile and desktop. I said it yesterday in the workshop, I sometimes really, really do disagree with these things because I don't think it really makes sense. I do get funny things sometimes where I'm like, no, it's not right. I totally disagree. It's a bit of a bold statement, but if you try that out, and we'll maybe see that later, I think you will also agree. All right, so we've seen a lot of tools, and there is like another one that I'm really in love with because it gives you that one value that I'm really interested in, which usually it's hard to get by, what I said with First Paint. So it's called Navigation Timing API, which gives you a lot of events, like 21 at a number. And you can use all these events and like subtract values from these events, and it will give you page load, or like, as I said, my favorite one is like First Paint. So luckily enough, we don't have to remember all of that. If you're interested, like what happens, it looks pretty much like that. And then you just like subtract values. You can just do that via JavaScript. This one down here is like the example for like how to get to First Paint. It's nice, you can do that. You can also like hack that right into your console, but you don't need to because there's people who do that stuff for you, and there's awesome tools. So thank you, Adi. This one is timing.js. It's I think it's available as npm module and also like a bookmarklet. And I mostly use that bookmarklet, and it just like spits out like a little table in your console, which looks like this. And then you have right here First Paint time, and then it gives you the value. So this is really helpful and one of my favorite tools to use. And check it out. It's very, very helpful. All right, low-hanging fruit, I talked about that before. I think I have to speed up a little now. I want to get to that interesting stuff, and I don't want to run too late. Low-hanging fruit, basically, little effort, massive gains. This is like where you can optimize a lot. I'm just going to go through that quickly. I think this one is always very important, images. Whenever I talk about it, I feel silly because I think it's such a no-brainer, and everybody should know that by now. No, people don't. I'm always surprised how many people don't use ImageOptim or tools like that. Anyways, images account for like a majority of like page size, so there's a lot of room to optimize there. What I mentioned is now, who of you knows and uses ImageOptim? Wow, everybody else later download it right away. Magic. You'll see now. So basically what you do, you throw in a folder of images. This one was like something a client sent to me, and they probably would have uploaded it otherwise right away. And then this is actually the result. So 50%, more than 50%. It doesn't happen all the time, but this one was like, yay, cool. So another thing, scalable vector graphics, SVG. You can use those for like icons or logos that will also like reduce file size. Image sprites is another one that you can use to save additional like round trip times and requests. Then there's also data URIs and base64 encoding, where you can theoretically, or you can like inline images into your document, which basically loads the image right on first request, so you can pack it into like the first, I don't know, 8, 12, 20 KB if you want to. Not cacheable, not indexable, so I don't know, it really depends. Careful with that one. Optimizing JavaScript and CSS, I think we all know, concatenate, minimize, uglify, all those things. Very, very important, because like reducing file size and so on. I know like a lot of people usually like use a lot of frameworks, Foundation, Bootstrap, and so on. Comes with a lot of bloat. If you want to get rid of that bloat, UnCSS is your friend. Basically, you throw in your site, and it removes all the unused CSS, because it reads all the classes that you have in your project, and then spits out or throws out all the unused ones. Doesn't work on dynamic files like PHP and stuff. There's like apparently CSS Nano or something that works on dynamic files and does the same thing, which I didn't know, found out yesterday. So basically you can get from like 15,000 unused rules, like, hey, Harry loves that. I don't know, 55 or so, because like whenever you have like maybe some pages, it also doesn't work for like dynamically set classes via JavaScript and so on. But this is like much, much better. All right. So now we got that basic stuff, and I think there's hopefully like a little bit of like prerequisite on people know that already, but now is the much more interesting stuff where I get a bit more excited about. So optimizing for like extreme performance, whereas like extreme performance, I'm not sure if I like that word, but it's kind of like taking that stuff and then you put in a lot of work for like very little effort, or very little outcome, like chasing milliseconds and stuff. So there's something called optimizing the critical rendering path. And this is like where you also can gain a lot of ground. So we have render blocking assets. And render blocking assets, for example, is CSS, JavaScript, and also your first index HTML or your HTML file. Basically what happens when the browser parses the document, it reads the document from top to bottom, hits the CSS, and because we don't want to have that like flash of unstyled content, which would basically mean like you load your naked structure, or like your document structure, and then a few seconds later you put your CSS on top, and suddenly it looks pretty. We want to avoid that, so that's why the parser stops for CSS, starts reading the CSS, and then goes on, reads the rest of the document. The same thing happens for JavaScript as well. If you put JavaScript in the header of your document, it also stops for that, reads the JavaScript, executes it, and then goes on. So this is why usually it's a good practice to put JavaScript at the bottom of your document, because then you get something to see fast, and then JavaScript, usually you only need it a few seconds later, if at all. You can use JavaScript as loaded as async, so that means like it loads asynchronously and then there's no render blocking. But generally, there's also like kind of sometimes interesting results with that, because like I've had a project where I put it at the bottom of the document and async and defer, and it all kind of did really not make sense. So I picked one that was like the fastest, and I'm happy with it. I cannot explain why, and sometimes these things happen. So that was. Yeah, that looks something like that. You just throw in async attribute, and then it doesn't render block. You could also use defer, which basically means like postponing executing the JavaScript right before document content load. Yeah, DOM content loaded. So this is also something you can experiment with, like depends on your project. So a critical rendering path basically consists of like a critical resource, which is like your resource that you're loading, whatever, can be CSS, JavaScript, and so on. Critical path length, which is the time it takes to load that resource. And then critical bytes is the size of it. Then also we want to limit our HTTP requests, because every request basically takes about like 200 milliseconds, sometimes a bit more, sometimes less. So if you throw in like 30 CSS files into your head, you get like that render blocking. Plus, you have like 30 round trips, 200 milliseconds each, which you do the math, adds up, and then it's just pretty much slow. So optimizing the critical rendering path basically means getting stuff on the screen fast. So we want to minimize number of critical resources, critical bytes, critical path lengths, and as I said, critical resource is the ones that block render. You can see that here in like a waterfall. So the first one, index or like index the HTML file, is always render blocking, obviously, because you need that document. So you can see this one is the HTML. It ends here. Then there's like the CSS kind of starts here. So it only starts to load once this file is done. And then once these two are done, other stuff can go on. And this is usually like up to 6 resources per connection. Not going to go into that too much detail, but there's like tricks how to get around that with like domain sharding, if you heard about that. But that is too much of details for the last 10 minutes. All right, you don't have to do that all by hand. You can extract all your critical CSS. There's tools for that. So basically you can get the critical CSS for your visual viewport and you extract it via tools. Then you can either put that in a separate file or you inline those styles, which basically means like in the first request, you have like a very first like rendering of your visual viewport, and everything that you don't see, you can load that stuff later. So this is like a very good way on like optimizing this stuff. Basically taking everything that you need for your first viewport, take it out of your other files, get like a small portion of that and load that. All right, so why are you all here? Because we want to forget about all that stuff and we want to build with like H2, which is like much more fun. This is going to be a big, big change in the future, and I'm really looking forward to that. So with HTTP 1, it was mainly about like limiting TCP connections to reduce the load on the server. And what I said before, there's tricks on how to get around those connections. But basically, the idea was to maintain 2 connections at a time, and then you can hold like 6 TCP connections at a time, meaning like you can load 6 resources via 1 connection. This is like why you see like those waterfall lines mostly come in like 5 or 6. If you use domain sharding, you can open like 2 connections to like a subdomain, which gives you like 6 and 6 at the same time. So this way you can get around those limitation of like 6 resources. But now we're forgetting about that because now, hey, multiplexing, which basically means you can load everything via 1 connection at the same time. And that is pretty cool. So HTTP 2 also comes with like compressed headers, meaning like less overhead to send. Asset prioritization and dependencies, which right now is like rarely implemented. You can pretty much forget about that. And server push, this is also something I got very excited about and makes a big difference. But it basically means that you request your first file, and that file, or you tell the server, if you request this file, you also need this one and this one and this one, and there will be no round trip for like the request because the browser just knows, okay, give me that one and give me that one, and it's lightning fast. All right, so before we can all do that, you need to kind of like get to HTTP 2 and get it running. So first of all, you need a SSL certificate. Without that, no go, no HTTP 2. Fortunately, Let's Encrypt, you can get that for free. Very good. Also, you have additional benefits because Google is also very happy about having secure sites. So this will be the next big thing where like they will favor secure sites over non-secure ones. Then you need a server. So you can either do that like with Apache module. I usually do it with like Cloudflare, which is like a CDN service. There's other CDN services that also allow you to do that. It's the fastest and easiest way to set it up. Nginx also supports HTTP 2, whichever one you prefer. Then you need a supported browser, which nowadays is quite good because most current browsers support HTTP 2. And the interesting thing, everything I said before, or not everything, but parts of it, you can forget about it because you have to unlearn it now because everything is different. Welcome to our world of technology. All right, what has changed? Concatenation of files. So, as I said before, this is good practice now. In HTTP 2, you don't have to do that anymore because you can basically get like all your CSS files and JavaScript files and like break them up into little small modules because you can all load them at the same time. And this allows you to get like very granular control over what you're actually loading, very modular. Then, yeah, basically, as I just said, requests don't matter anymore because we don't have to wait anymore. They can all come. You'll see that in the next waterfall chart. Then you can probably simplify your process, like build tasks and so on, because you don't have to concatenate everything anymore. You can just leave it as is, minify it, and pew, off you go. It's pretty good. One thing to watch out for if you have aggressive caching or like proper caching, and you have like a lot of modules that like change frequently, you might want to look into the caching because that could cause problems. Interestingly enough, Facebook, all H2 now, they're doing this. So they have like 1, 2, I don't know how many, up to here is all CSS files, and JavaScript starts here all the way to here. So you can see they're making use of that already, delivering like very small modularized assets. So this is the HTTP1 waterfall. We've seen that before, as I mentioned, render blocking, then you have those two, then everything else, and the other guys come like in pairs of I don't know what. HTTP2 looks more like this, and this is awesome because everything can go through that one connection. Very, very helpful. Again, image sprites, we talked about that before. That was like mainly to reduce HTTP requests. Forget about it, you don't need that anymore. You can ship like hundreds of images. Really doesn't make a difference. There's some cool tests. If you Google HTTP1 via H2 comparisons, there's like some sites that have like how they load images in like, I don't know, maybe 200 small little squares broken up. It's incredible how fast H2 is. It just goes like, maybe H1 is like 6 seconds, H2 is like a second or so. Big difference. So don't worry about those images anymore. Inline images, also, same thing, not cacheable. You don't need to do that anymore because you can just load it with H2. And now I only have like 4 minutes left for the exciting part. Yay, server push. So as I mentioned before, server push allows you to get or like receive files without requesting them. And I'll show you how that is done. So there's one way on how to do it, is via a link element with like a preload. I have to be honest, I tried it this way. I could not figure out how it works, and I don't know. If anyone knows, I'd be happy to have a conversation about that later. The as attribute, for now you can omit that because it's mainly interesting for the prioritization that I mentioned earlier. But since that's like not widely or not at all supported yet, you can omit that. The other thing that I actually did manage to get implemented is like you have to send a header, and that looks like this. You can also chain those up. You have to really watch out for syntax because it can be very subtle. Like basically you have to separate them with a comma, which took also a while to figure it out. And then it actually does work. If you see it in developer tools, it looks something like that. So it says push, okay? And you see there is very little time for normal sized files. I don't know, like, yeah. Super, super fast. I tried that on a pet project of mine. So this was like with pushing one resource, and I got 678 milliseconds to page load, which is quite awesome. From Hong Kong, it's about like 1.5 seconds, which is always awesome when I come to Europe because like things are fast, yay. So then I was experimenting with that and playing around with it a little bit. And this one also loads just like one CSS file and one JavaScript file, 50, I don't know, this is like 50K or so, the JavaScript. And then I tried to like actually push 3 resources, and I got first paint of 287, and this one has load of 700 something, but that's like pretty impressive because it was fast before, but this is just, I mean, 200 seconds or 200 something milliseconds to first paint is pretty fast. Domain sharding I mentioned. This is a good overview of like what changes. So basically all the first ones stay the same. Domain sharding you have to be careful with. Concatenation, remove it, and inlining resources also remove. And I think I'm running out of time, huh? Almost 2 minutes, okay. So you want to run on HTTP2. So first you have to check, does your server support it? Make sure you have an SSL certificate if you want to get all that implemented. Then you have to prepare your assets, adjust your build process if you want to do that. Browser support, also important. Check your analytics. If your majority of users don't have browsers that support HTTP2, there's little point of implementing it. Even though it's backwards compatible with H1, you can like just do it and it's going to fall back, but you might want to hold out. So make sure you check your analytics and see if your majority of users actually have browsers that support it. Well, and then you just pick the ones of the techniques that you like best and start implementing them. And one thing to note is like it's not only about technology, it's also about like a philosophy and acknowledging that like this whole stuff is like important and you need to do that. And sometimes like when you work with like teams or companies or for clients or stakeholders, which sometimes can be painful, but you have to kind of like convince them to actually why this is important. Sometimes this might like require cultural change, organizational change, and so on. But this is like what we've been talking about, like design process, development process, and all that, like for quite some time. So remember, web performance optimization is just not a one-off. It's like an ongoing explorative journey and not just like one point where you just get to. So that was it for today. Thank you very much.